So this is page 3 of the study guide. This first problem on here is actually multiple parts. So it says, Mark has been tracking the stock price of Energy Corporation over the 45 days since it started trading on the New York Stock Exchange. Mark plotted his data on the graph and used a Quartic regression to generate a polynomial function to best represent the data. All right. Now we want to be careful because the regression is the curve. The little dots are his actual data points. So when it says for part A, according to the Quartic regression, that's the actual curve here. All right. During what days was the stock price the highest, and approximately what was the price? Well, if we start going through our answers here, we can look at this and absolutely say, well, day 4 is right around here. And yeah, that's a high point, but this is higher. Okay. So then if I look here, this is 32, 34, 36 is right here. So if I go up here, yeah, there's higher points than that. So now I'm going to move over here, and these last two are day 39. And it's either going to be $9 or about $9 or about $9.50. So I'm going to zoom in just on the picture. And if I look at this, yeah, it's between 38 and 40 days. So 39 makes sense. But remember, we're answering the question based off the curve, and this curve has a high value of 9. So be careful when you're answering this. The answer is C. It's about day 39 and about $9. It's not the highest dot. It's the highest part of the curve because it says the Quartic regression. Okay? During what day or days was the stock price predicted by the Quartic function unreasonable? Okay. So if we go over here, and again, we have some options here. So 8, 10, here's day 12. It's predicting a little bit more than $2. Totally reasonable. 12 to 16, no, these are all reasonable. 17 to day 23. Well, here's the problem. Stock prices don't go negative. So that's unreasonable. So let's go ahead and circle that up. And then day 36 is way over here. So we're up here to day 40. No, those are all totally reasonable prices. Okay. Let's see. According to the Quartic regression, during which days was the stock price increasing? So let's break it down and take a look at what we've got here. Day 4 to day 14. So 2-4 to day 4. No, this is all decreasing, right? This graph is dropping here. All right, so let's see. Day 14 would be right here to day 23. No, these are decreasing. Okay. Let's see. Day 23, which is right around here, to day 39. Yep, that is a big old increase in the graph. So it's right here. And day 40 to day 40. Yeah, no. Day 40 to day 45, we're dropping again. So there's only one section in these answers, all right? There is one other part of the graph that's increasing, which would be this little part right here from about day 0 to about day 4, all right? So there would be another possible answer there depending on the way the question was worded. Okay, using the Quartic regression, so we're going to use the curve, determine the average rate of change over the interval 38 to 44. So on day 38, I want to know what's happening with my money, or the stock price, I should say, not my money. And on day 44, I want to know as well. So day 38, let's go ahead and look at our graph. And it's again the regression. So I'm going to call that a straight up $9. All right, so that's 9. And then on day 44, so this is 40, 42, 44, we're right around $5. All right, and you can just see me. I counted up on the x-axis, counted over, and then I'm following this back to the y-axis to get my stock price. So that's going to be 5. All right, so there we go. We now know we're trying to figure out what's happening between these 2 points. So I am going to set up my slope. I'm going to take my second y minus my first y over my second x minus my first x. So let's see, 5 minus 9 is going to be -4, and 44 minus 38 is 6. I'm going to go ahead and divide this out, and I get -0.6, and I'm going to round it off to 0.7. It's -0.6 repeating. But the reason I'm going to do this is because what this is actually telling me is what I'm going to explain in part E is this is how the cost is changing per day. All right. So because I know this is cost or the stock price, I'm going to go ahead and just leave it as 2 decimal places. All right. Explain your answer to part D in terms of the problem situation. So the first thing I start with is the interval. So from day 38 to day 44, I believe it was the price of the stock. Let me double check. Stock price. Yep. Okay. The stock price was decreasing. And I know it's decreasing because this average rate of change is negative. Okay. It was decreasing by an average. Let me actually pinch in here so you can see it all. By an average of 67 cents per day. Okay. So over the course of that time, every single day, the stock price was dropping or decreasing an average of 67 cents. All right. That's what's going on in that situation. So tell me about the interval. Tell me whether it's increasing or decreasing. And then it's always an average of something per your unit of time on the x-axis. So if this was in years, you would say per year. If this was in months, it'd be per month. All right. Now, problem number 11 says to use your graphing calculator. You absolutely could use your graphing calculator. You also can use Desmos. You can use any technology that works. So let's see what I've got. I've got Desmos up here. So I'll do one of these with Desmos. And I will show you the other one with Calculate 84. You pick the one that makes you happier. So in Desmos, I'm going to put this whole expression here. All right, so in parentheses, let's see, we've got x minus 4 squared. And take your time, make sure the equation's going in correctly. So as I'm doing this, I'm double checking to make sure I'm not, putting something in wrong like I just did. So +1, not -1. Let's see if I double check that. X plus 1, x minus 5, and let's see what I got here. X minus 4 squared. Okay, so I'm going to go ahead and shrink this part back. And now I want to look for the interval -1 to 3. So here's -1, 1, 2, here's 3. So somewhere between these two, okay, those two x values, I want to find a relative minimum. So I'm looking for a low point. So I'm going to just use my finger and I'm pushing Desmos. I'm pushing the graph up. Graph. Okay, there we go. All right. And what I just did at the very bottom was I tapped on the actual graph itself. It darkens it, and it also gives me these little gray critical values. So this gray value right here is the actual relative minimum. So it says round to the nearest hundredth. Hundredth is 2 decimal places. Let me not write with highlighter here. So let's see, 0.32 and -83.66. That's my minimum. And it also asks me to sketch the function. So let's see if I can see this function. There we go. It's not too awful. Now, a sketch is just that. I am not looking for perfection. I am not looking for anything, too exact. Please don't think you need to label out the x-axis at all. The reason I ask for this sketch is so that if you did something other than this sketch and you told me a relative minimum, it means you didn't put the graph in correctly into whether you calculate 84 or Desmos. All right, so that was all it is. All right, now I'm going to close this out. And I'm going to then do problem number 12 with Calculate 84. But in order to do that, I need to actually get Calculate 84 up and running. So there's Calculate 84. Let me go ahead and clear all this mess out. I'm going to go into y equals, clear that out as well. And let me go ahead and split screen back to the, there we go, back to Notability here. All right. So in Calculate 84 here, I'm going to go ahead and put this expression in, right? We already have the y equals. So again, I'm going to make sure I take my time, put the expression in correctly. X plus 8, and then x plus 2, close that up, double check it. All right, I'm all good. I'm gonna hit graph and it looks fabulous. What I'm gonna do here is I'm actually gonna select zoom and I'm gonna zoom out possibly multiple times. So zoom is number 3 here. Oh, and nice. I love that part. It just read the little directions. It says you can, let's see if I can do this. Nope. I thought it was telling me I could pinch in on it. Oh, I can pinch in, but I can't zoom out. Oh, that's not lovely. All right. So I'm just keeping on hitting zoom out, and eventually I might see the whole graph. And you're not going to break the calculator, and I'm talking about, Calculate 84 as a calculator. You're not going to break it if you do this. Let's see. Let's go 1 or 2 more times. You could also, if you wanted to, change the window. There we go. It just takes a second. So first thing I'm going to do here is a little quick sketch. All right, I know it's coming up. It's going back down. There we go. Quick little sketch here. And I am looking for a relative maximum from -10 to -1. And I'm guessing it's going to be this point right here, but I'm going to actually make my calculator find it for me. So I'm going to calculate that. So I'm going to hit second calculate. And I'm looking for a maximum. So I'm going to hit number 4. Now, you'll notice the little black dot here, the black X. It's actually a blue X. Wow, I can't tell my colors right now. And you're asked for a left boundary. So what I want you to do is scroll to the left or, hit the left arrow until you get X to be -10 or close to -10. Whoops, too far. All right, so close to -10. I'm going to go ahead and hit enter. And you'll see the little line up here that says this is your boundary. Now it's asking for a right bound. So I'm going to use the other value for our interval, which is -1. So I'm going to scroll to the right until I get to -1 or something close to it. Now, down here, you have your actual maximum value. All right, this other point here is where the little dot is, but the max is the little box up on the top. So this is our actual ordered pair here. So relative maximum here is going to be -5.42. Remember, you're rounding to the hundredths place, so 2 decimals. And 91.94. Now, for these problems, whether you use Calculate 84 or Desmos or other technology, it won't matter. We want you to actually play with the technology and get used to working with it. All right, so I'm going to go ahead and close the video out on this one, and I will put up a separate video for problem